All right, so today we're going to talk about extending Ruby with C. So in case you guys don't know, C is a more basic language. C is what Linux is written in. It's what lots of different low-level things are written in. And in fact, the Ruby interpreter itself is written in C, at least if you're talking about the Maths Ruby interpreter, which is the standard one that most people use. So the idea is that since Ruby is written in C, you can write an extension to the Ruby interpreter in C. And this is pretty well supported, and there are lots of gems that do it. For example, I think Unicorn is a C extension, or it uses one. And when you install the gem, you'll see it says building native extensions. That means it's building the C extension. It's building some code that's written in C, and that code can very tightly be coupled with the Ruby interpreter, and it can also be tightly coupled with the C world. So let's talk about that. So first of all, why might you want to make a C extension? I think the main reason is that you might want to access some C libraries from Ruby. There are lots of good libraries out there like libusb or ImageMagick, and by default you can't just call C code from Ruby because C is a very different thing than Ruby. So people write these extensions that are C code that interacts with the Ruby, and they bridge the gap between the Ruby and the C library that they want to call. Another reason you might want to write a C extension is if you just find that Ruby is too slow for you. If you try it in Ruby and find that you need this algorithm to be faster, then it's a good idea. It might be a good idea to write a C extension. And the other thing, even if none of these situations apply to you, this topic might still be interesting because it lets you learn more about how the Ruby interpreter works, how the insides of it work. And so you might have more insight into how Ruby itself works. All right, so what can a C do? First of all, it can do almost everything that Ruby can. It can convert Ruby data from Ruby objects into C data. It can convert between Ruby and C data, and it can go the other way as well. It can call methods on Ruby objects. It can define its own classes and modules, methods, constants. It can throw and rescue exceptions. And that's kind of a magical thing because C doesn't normally have exceptions. The C extensions can access Ruby variables from other objects. They can define blocks and yield values to blocks. And as I said before, they can be packaged in a gem. But of course, they can also do a lot of things that Ruby code can't. So your C extension, one of the things about it is that it basically looks like the source code of the Maths Ruby interpreter. So I think you can call pretty much any function inside the interpreter. And that allows you to do lots of interesting things. So for example, you can store a hidden pointer inside a Ruby object. So that's how you can associate a Ruby object with some C data structure. And that's useful, and I'll go into more depth later. You can add hooks to the Ruby interpreter, and that could be useful if you want to write a profiling application like RubyProf. And you can do some funny things with global variables. Like you can actually define one that's read-only, and you can define a global variable that detects when it's being read or being written to. And I just thought I'd throw that in there because I don't really know why you would want to do that, but it's an interesting thing I found. In case you haven't seen it yet, global variables are those variables in Ruby that have a $sign at the beginning of them. And they can be accessed from anywhere in your program. So just because C is a new language, I thought some people might be intimidated about it and think, oh no, this is hard, I don't want to learn this, I can't learn this. Well, I wanted to show on this slide that it's actually very easy to get started writing your own C extension. Because on the slide I have all the information that you need to do it. So the first thing you need to do is write the source code of your C extension. And for this very simple, minimal example, we'll just call it myextension.c. Oh wow, that barely shows up.
There it is.
Okay. Yeah, so we need to include ruby.h, that's a C header file that is part of the Ruby interpreter, and it gives us access to all these functions in the Ruby interpreter that will allow us to interact with it. Then we need to define this init method, and the suffix myExtension here has to be the same as the name of your C extension. And when your extension gets loaded by the Ruby interpreter, that init method will be the first thing that runs. So it needs to set things up. But normally you would define some classes or define some methods in that init method, in that init function. But for now, we're just going to call printf, which prints to the console. Now, to compile this, there are a couple steps. First, you need to make this extconf.rb, stands for extension configuration or something like that. It really only takes 2 lines. You require make-mf. The second line is optional, but I added it because it lets you use a modern version of the C language that lets you be a little bit more flexible where you declare your variables and stuff like that. And it's basically just defining an option to our compiler. If you want to define other options to your compiler, you would add it in there. And the third line is just kind of boilerplate. It tells it to create a make file. So when you run this extconf.rb, it will create your make file. And then to actually build the extension and compile it, you run make. So that'll invoke the C compiler. It will build something called myextension.so. At least that's what it's called on Linux. I think on Mac it might be .dilib. But anyway, this is a dynamic library that then can be loaded into the Ruby interpreter. And how do we do it? Well, we load it just like we would load a Ruby program, actually. You can write a require statement or require relative and give the name of the file. And even though the file would have a .so extension on it, you don't need to put that here. The Ruby interpreter is smart enough to find the .so, load it into memory, and it runs your init method, and you get the result, hello world. So that's the most basic C extension. And I'm going to go through some more C extensions, some more things that you could write in a C extension. And the idea is that I'm showing some examples of what you could do with a C extension and how you could do it. And maybe if you start writing a C extension, you might refer back to these examples to remember how to do it. But there is other documentation too. Anyway, so I'm going to show the Ruby code, what we want to write in Ruby, and then below it I'm going to show the equivalent code written in C. So here what we're doing is we're just defining a class and defining one method in the class, and it just takes a single argument and it doesn't do anything, it just returns nil. So this is pretty much the most, this is starting to get useful because we actually are going to define a class in our C extension. So the new thing that you'll notice on this slide is that in the init method down here, we're calling RB define class. That's part of the Ruby interpreter. It defines a new class. You have to give it the name of the class, which we'll just call it my class, and you have to give it the parent class. So this is a lot like in Ruby, when we wrote class, my class, we were opening up a new class. And you can do an exact equivalent thing here in C. But we have to keep track of the return value. So we're going to get an object back from the RB define class method, and it represents the class. That's a Ruby object that represents the class. The second thing we do is define the method. So we call RB define method. And to define a method, well, what do you need? You first need to tell it what class the method is in. Then you need to tell it the name of the method. And then this third part might be a little bit confusing, but the third argument here is a C function pointer. So we're telling the Ruby interpreter so it's actually a function pointer to the function that we defined above. Now this thing doesn't work too reliably. I'll just use the cursor. So we're giving a pointer to this foo function, and we're telling the Ruby interpreter, this is my foo function. We're gonna make a Ruby function named foo, and the code that gets executed when someone calls foo is in this. It actually is the C code right there. And then the last argument to RB define method is just the number 1 that defines how many arguments this thing will take. So then in the foo function itself, you'll notice that it takes 2 arguments. So I said it was only going to take 1 argument, but it takes 2. And that's because the first one is actually the object that is receiving the method call. And that's important because in Ruby, you always need to be able, there's always this concept of self. And you always need to be able to access self and call methods on self or look at the instance variables in self. But we're not doing anything in this method yet. We're just returning qnil, which is just how you refer to nil when you're writing a Ruby C extension. All right, so are there any questions about this slide?
That RB-C object, is that defined in the ruby.h?
RB_C object, yes. Yeah, that is. You get access to all this, pretty much all this stuff is defined.
So can I actually have a function pointer to an actual C function in there, or does it only, or does the RB define method only take like Ruby methods defined in C?
It has to have a particular structure to it.
Right.
You can't just expect to get an int as the first argument or something like that.
So anything you pass into the Ruby interpreter has to be a Ruby function in C, and in order to bridge it, you have to define a special Ruby C function. Is that how it works? Yeah, that's like how Python works. Yeah, okay.
Yeah. So you'd have to, if you had a C function.
If you had like a C struct and you wanted to pass it in, then you would have to first convert it into a Ruby object with one of those things. Is that how?
Yeah, basically.
Okay.
So I'll talk about that later, but basically you can have a Ruby object that holds a pointer inside it, and if you construct the Ruby object specially to hold a pointer to whatever you want, and then you could pass it around through the Ruby world. Yeah. All right, cool. So just a basic example, just define a class, define a single method. And you'll notice in the previous example there was this value type that we were passing around everywhere. Basically the value type simply just represents a Ruby object. That's how they're represented in the Ruby interpreter. And it's interesting to look a little bit about how value works, because it tells you a little bit about how the Ruby interpreter behaves. A value is actually just an unsigned long, so that means it'll be a 32-bit number on 32-bit machines and 64-bit on 64-bit machines. And generally, the object is actually a pointer to a Ruby object, which is represented as a C struct. But it's not always a pointer. Sometimes, so if the least significant bit is set, if the least significant bit is set, that value actually just represents an integer. And the other 31 bits in there are the value of the integer. Or, as you can see on the third line, if the least significant byte has that pattern, 00001110, if it has that pattern, then that is a symbol. And the value of the symbol is determined by these other bits. So that's interesting because that means you can compare two symbols just by comparing these two 32-bit numbers to each other. And so that would make symbol comparison much more efficient than string comparison. And you can also see that false, true, nil, and undefined have their own special values in there. Now, the value, there's a thing called the type of a value. And type is not the same thing as class. Type basically represents what kind of data is this thing pointing to. And there's a fixed set of them. And here's the complete list. You can use the type macro on the Ruby object to figure out what type of thing it is. And it'll return one of these values. So for example, if it's nil, the type macro will return t_nil. If it's an object, the type macro will return t_object. If it's a thing that wraps a pointer, it actually returns t_data. So here's an example of using that. So here's a C extension, well, a method inside a C extension that will take a Ruby object, figure out what type it is, and give you some information about that. So this is just demonstrating that we're able to convert Ruby data into C data. So we take this argument, obj, we call the type macro on it, and if it's a fixed num, then we can call this num to int macro and get the value and print out the value. Get the value here, just print out the value. This is just normal C code. Then if it's a string, there's a special function for getting a pointer out of that. Because in Ruby, a string is basically a pointer to some data and a length. And we can extract that pointer and we can deal with it in the C world and we can look at what's inside it. We can also figure out if the thing is an array, and we can use this another special macro to get the length. All these things are defined in ruby.h, or maybe they're defined in headers that are included by ruby.h. And there is some pretty decent documentation where you can look up these things. But anyway, the result of that is that we have this foo method, and we can pass it various different Ruby objects, and it can figure out what type they are, and it can do the appropriate thing. So that's how we bridge the gap between this Ruby world where everything can, there's no static typing, any object can be any type, and the C world where types are known and fixed ahead at compile time. That's how that gap is bridged. And it can go the other way too. If you have some C data, you can call some methods to convert the C data into the equivalent Ruby data, and you can package it up and you can return it, and it goes back to the Ruby world. So for example, here's a function called foo2, and what it does is it returns an array with hello and 44 in it. So the way we do that is we just create a new string with hello in it. So it takes this RB stir new2. There are actually like 6 different ways to create a Ruby string. So you just kind of have to look around and figure out which one is the best. And RB stir new just takes a C string and returns the Ruby string. So that was the most easy one to use in this case. Int2 num will take a C integer and return a fixed num. And RB array new3 is what we need to use to put those two together into an array, and then we can return the array. So this is kind of a lot of code, but it works, and then you get that value out at the end. All right, another thing you can do from a C extension is call Ruby methods, and I thought it'd be interesting to show how that actually works. So this is the Ruby code that we want to implement. We want to take a single object and add the object to itself. Now in Ruby, it's interesting that the plus operator is actually implemented as a function call. So when you write a plus b, it might look kind of special, but it's actually very similar to writing a dot plus b or a dot concat b. It's just a method call, just like any other, but the name of the method happens to be plus. So the way we can represent that in our C program would be to use this RB fun call. So when you're calling a function, you need to tell it what object you're calling a function on. You need to give it the name of the function. But actually, you don't just give it the name, you give it a symbol. So we have to call RB intern to get a symbol from the plus string. And that's interesting because you know how we talked about how symbols can be compared very quickly? And here we see that symbols are being used in order to call functions. So I think that was part of the design decision. That's probably why, I would imagine that might be why symbols exist, to make it more efficient to call these methods and find the right method. Because it's more efficient to compare two symbols to each other instead of comparing two strings. And then we need to pass in the arguments. So we have to say the number of arguments and then have all the arguments on there. And this is how we call a Ruby method from C. And then we just return the result on the next line. So we can pass in the string boo, and we get boo boo. We pass in the string 44, and we get 88. And it's interesting because the C code is doing this dynamic thing. The C code will work with either a string or an integer. And so it's behaving dynamically, kind of like Ruby code. You can also raise an exception in your C extension. So if you call RB raise like this, and give it the class and the exception method, then that will actually raise an exception, and the line after it doesn't actually run. And I thought that was pretty interesting. They use this thing called set jump and long jump to make that work. At least the last time I looked into it, that's what they were using. And so yeah, you run this and you get the expected result. If you pass in the value 800, it's too large, and you get this nice exception printed out on the screen. As I've been saying before, your Groovy objects can hold a pointer to a C data structure. And here's a drawing of what that looks like. You have these Ruby objects that are living in Ruby land. And this one is, the top left one is special because it holds this pointer to a C data structure. And I've drawn the C data structure down here. You can define what that data structure is, and it can hold pointers to other things like an array or it can hold handles to files, or it can hold open a handle to a USB device, or something like that. And it can also even hold references back to other Ruby objects. But if you do this, you have to tell the garbage collector about it, because otherwise the garbage collector might end up collecting this object when it has no references left, because the garbage collector doesn't know that your C object is hanging onto this reference. So yeah, it's possible to do that, and the way you do it is when you create this Ruby object, you have to create it in a special way so that it has a spot available for that pointer. So to create it in that special way, you have to call data wrapped struct, and you give it the class name. And in order to interact with the garbage collector, you have to specify a mark function and a free function. These are more function pointers. And then you can specify the initial value for the pointer, but you might as well just specify null there, because you can change the value of the pointer later. And to really understand how this fits in, I think what you should do is call this, you have to call this when the new object is created, and the place where you should actually be calling it is in the allocator method of the class. So everyone probably knew that Ruby classes have a method called new. You call that in order to make an object. And they also have a method called initialize. But what you might not know is that a Ruby class has this allocator method, which is kind of this implementation detail, but when you're writing a C extension, you actually get to write your own allocator method. And that can help you. The idea with that is that you get to decide what type of Ruby object you're going to create. Is it going to be an array type, or is it going to be a type that holds a pointer, or is it going to be some other type? So the way that works is when you call object.new, it takes all these arguments in. It calls the allocator method to allocate the memory, but the allocator doesn't get to see any of those arguments. And then it calls the initialize method to initialize the state of the object, and that's when you actually get to see all these arguments. So the basic strategy here is that in the allocator, you should call that data wrapped struct method that I showed earlier. But you don't have any data yet, so you can't really set it to anything meaningful, so you should just set the pointer to null. Then in the initialize method, you actually have access to what the user passed in to create the object, so you can actually initialize your C data structure. You can call malloc to initialize some memory. You can call open to open a file handle. You can open a handle to a USB device, or whatever you want to do. And you can do that in initialize. Then you should be sure to free all that data when the object is garbage collected. And in general, you might need to add this close method so that people can close the object early if they want to. For example, if you're holding a handle open to a USB device and it's this exclusive handle and nobody else can access the USB device, it's important to let the user close that handle. Anyway, I put that all together into this example here that kind of puts all the pieces together and makes that work. There's a struct here that I define called myData. It has an integer x and an integer y. When we define the class, we tell Ruby what allocator function to use. And in the allocator function, we allocate space for the pointer. We create the object and allocate space for the pointer in it at the same time. And there's some other little things you have to do, but at the end, what you have is you can define these getX and setX methods that they have self as the first argument, extract the data pointer from the Ruby object, and then they can use that pointer to either read or write from the underlying C data. And this is all the code you need to make that work. All right, so now you've seen a bunch of examples of different things that Ruby extensions can do. And there is a lot more, but I wanted to zoom out a little bit and go to the high-level overview. So Ruby extensions are only supported on the Max Ruby interpreter and Rubinius. I looked into it the other week. JRuby kind of used to support them, but there haven't been enough volunteers to maintain that. So they actually deprecated it in the most recent version, and it's disabled by default. And it sounds like they're going to get rid of it. So that's an important thing to consider if you're going to write a C extension. And also, you don't always need to write a C extension. At the beginning, I said you should write a C extension or you might want to write a C extension if you have a CPU-intensive task where you need to access C libraries. But there are other ways to do both of those things. If you wanted to write some C code as part of your application, you could write like a command line interface. You could write just a standalone program in C, and you could call it from Ruby, just like Ruby can call any other program. Ruby can call ls, Ruby can call grep. It can interact with other programs on your computer. The only drawback of doing it that way, though, is that you don't have a very good connection between the C code and the Ruby code. You have to serialize every bit of data that you want to get into the C code. You have to turn that into a string first, basically. That's basically your only way of sending data to the C code. And then the C code has to interpret that string, parse it, and figure out what you meant. Another alternative, this alternative could allow you to access C libraries without writing any C code at all, actually. There are these three things that are all kind of the same. They're called DL, fiddle, and FFI. And the idea with those, here's some example FFI code taken right off their website. The idea is that you define what C library you want to access, and you specify the name of the function you want to access. You have to specify the types of its arguments, and you have to specify the type of its return value. And if you do all that, and if you do it perfectly, and you get it right, then you can call the C function below. Or you can call the C function below, just like that. So this might be good if you just want to call one or two functions in a C library, but I wouldn't recommend this for anything more than that, because pretty soon the C library will get updated, and it'll get out of sync with your source code. Anyway, if you want to learn more, there are some great resources. Dave Thomas wrote a nice PDF about it, and it's available.